integration techniques, which is the last part for BC calculus, which is trigonometric substitution. Now, when we're doing trigonometric substitution, we have to substitute a trig function into 3 different forms. So you need to identify the forms of the integral. So let's look at what the form of the integral should be, right? What substitution to use, right? And what identity to be used to simplify the integral, right? So the first form is if you find any square root form with a squared minus x squared, we're going to convert that, use a trig substitution, which is x is equal to a sine theta. Okay, and the identity we will use is 1 minus sine squared theta is equal to cosine squared theta, right? Great. The second form of the integral is to identify with identify a squared plus x squared plus x squared. These are square root forms. So the substitution we will use is a tan theta, right? And the identity we will use is 1 plus tan squared theta is equal to sec squared theta. And the third form is square root of x squared minus a squared. Okay. And the identity we will use is x is equal to a sec theta, right? And the identity we will use is 1 sec squared theta minus 1. Sec squared theta minus 1 is equal to tan squared theta. Right. So the first one is number squared minus basically a number minus x squared. The next one is square root. These are all square root forms. So let us have a look at the first problem. The first problem is what we have done before, right? We can use geometry and then we will use trigonometric substitution to prove this, okay? So the first form of the integral, remember we have done this before already. We can use geometry. Remember, this is a function. This is a function that we are integrating over this boundary minus 3 to 3. So because we are integrating this function over this boundary, it's like finding an area of the semicircle. So I'll take out this bottom piece here. That's not needed because it's a positive square root. This is negative 3 to 3, right? And that's 3 there. And we're trying to find the area of the. So if you get a problem like this, you can just use geometry to solve. You don't need to use trigonometric substitution. You'll probably get it in multiple choice problems, right? So this is a 0 here. So now to find the integral from negative 3 to 3 of 9 minus x squared, the radius is equal to 3, right? So the area, so this integral here is actually equal to the area. Let's call this the integral, right? And the integral is basically the area. Integral is equal to area, which is equal to pi r squared divided by, is half of the semicircle, right? Pi r squared divided by 2 when r is equal to 3. So what's the answer we're getting? Substitute 3 there. We're getting 9 over 2 pi. Right. Now, let's see if you can arrive at the same answer using this trigonometric substitution form. So we have this integral in this form here. Okay. That's the form of the integral, as we can see. Right. So now let's say, let me rewrite this problem here again. Let's redo it by So we basically identifying this form to be a squared minus x squared. So we will say let, see this part here, we say let x be equal to a sine theta. What is a? Look at this. See the square root. And we got, so what is a? To find a, we need to take the square root of the number. So it has to be 3 sine theta. Let x be equal to 3 sine theta. This implies that we gotta go and simplify this, call this the integral, right? So if we have to simplify square root of 9 minus x squared, we need to say, okay, square root of 9 minus x squared is equal to square root of 9 minus, what is x? 3 sine theta. Squared, which is equals to square root of, let's bring all this down. Which equals, remember this is equation 1. We still need to modify that, right? So 9 minus 3 sine, so that is square root of 9 minus 9 sine squared theta, right? You can take out 9 as a common factor. So 9 into 1 minus sine squared theta. Now, question, the square root of 9 is 3, right? 1 minus sine squared theta is cos squared theta, right? And the square root of cos squared is 3, absolute value cos theta, right? Which is just equals to 3 cos theta. Okay, the reason why it becomes 3 cos theta, because the boundaries for theta here, you don't need the boundaries. Boundaries for theta, theta is supposed to be an element from minus pi by 2 to pi by 2. Right, the boundaries for theta here is, sorry, that should be included because sine of 90 is defined. This should be negative pi by 2 to pi by 2. That's the reason why we drop the absolute value, right? And the last one is theta is an element. You don't need to know the boundaries for the cos because you can just integrate without them. 0 to pi by 2 union pi to 3 pi by 2. Pi is included, sorry. Okay, so we are working with this integral. So we got 3 cos theta. So we know what the square root of 9 minus x squared is, right? But now, this is the simplification for all of this on the inside. So what about this one here? Finding the derivative of this because we need to know what is dx. So dx is equal to what's the derivative of sine theta? It is 3 cos theta d theta. Okay, now modifying this, remember what is sine theta? Sine theta is x over 3. And drawing our triangle, what is the type of triangle we can draw? We can draw a trigonometric triangle here. Why do we draw a triangle? To check if we are using the correct substitution. It kind of like verifies the substitution that we are using. So make sure your trigonometric form appears in the triangle. What I mean by that is, let's draw a triangle. Sine theta, theta is the angle. Sine is opposite of hypotenuse. There's x, opposite, hypotenuse is 3. And what's the adjacent? Adjacent is the square root of 9 minus x squared by Pythagoras. So great, we can see that the square root form appears in the triangle. So we have used the right trigonometric substitution. Now we can simplify the integral. Now let's simplify the integral. So the integral is now equals to integral of, what is 9 minus x squared? 9 minus x squared is 3 cos theta. what is dx? Dx is also 3 cos theta, d theta. Okay. Now we have a problem because we need to know from -3 to 3, right? So if x is -3, what is the theta value here? Okay. If x is -3, what is the theta value? So if we need to write for x equals -3, sine theta is equal to -1. Now, when is sine theta equals to -1? Let's look at the sine graph. So sine theta, when is theta equals to -1? So we want to know what is the value for theta here. Remember, we have to change the boundaries of the integral. If you change from x, these are x values, -3 to 3. So now we need theta values. So if x is equal to -3, remember that was a lower bound. Sine theta is equal to -3 over 3, which is -1. And sine is negative when it is negative pi, right? -1. And is 1 when it is pi by 2, sorry. Pi by 2 and pi by 2. That's so great. So what's the answer for theta here? This implies theta is equal to negative pi by 2. So I'm going to put negative pi by 2 here. And for the top, it will just become sine theta for x equals 3, which changing the boundaries of the integration. Sine theta will become 1. And when is sine of theta equals to 1? When sine of pi by 2. So theta is now equals to pi by 2. So great. So we have to change everything. Now you can forget about your previous integral. Now we're back to this integral, which is a trig integral. So 3 times 3 is 9. 9 outside. Minus pi by 2 to pi by 2. Cosine squared theta d theta. Now we have a problem because cosine squared is a power form. You remember how to integrate cosine squared? We did it in trig integration. Square identities where we have to use half angles, right? Where is it? Where is it? We did it before. See, cosine squared. What did we do? We said half into 1 plus cos. So it's something like this. So go back here. So what is cosine squared? We got to use half angle. Cosine squared theta is half into 1 plus cos 2 theta. Right, so we have 9 and we have half into 1 plus cos 2 theta d theta. Now it's easy to integrate because 9 times half is 9 over 2. Integrating this 1, you get theta plus integral of cos theta is sine 2 theta over 2. Remember, we're finding the integral of cos m theta d theta. That is just sine m theta over m plus a c plus a constant. But no constant here because we have a different integral. Then we're getting negative pi by 2 to pi by 2. Right. Now we substitute and solve. So 9 over 2. Substitute pi by 2 here. We just get pi by 2. What is sine of 2 times pi by 2? What is sine of pi? 0. How we know that? Please use the sine graph. Right? That's negative pi by 2. So that's negative pi. This is pi. And this is pi by 2. And that's 0. All the important points. Now, subtract the lower bound. Substitute the lower bound. Upper bound is pi by 2 plus 0. Lower bound, you substitute negative pi by 2. Right? And substitute negative pi by 2 here, sine of 0 again. Sine of negative pi. 2 times negative pi by 2 is negative pi. Sine of negative pi is 0 over 2. So plus 0 here as well. Right? And now what we have is we got 9 over 2. And now we have pi by 2 plus pi by 2. Because omit the zeros, leave out the zeros, right? That's out. half pi plus half pi is pi. So, did we get the same answer? Yes, we did. Remember what we had before when we did the area, we had 9 over 2 pi. And when we used trigonometric substitution, we ended up with the exact same answer. Are we good, guys? Do you understand?
Yeah.
Excellent. You find the link, you see the link. So you see, this is much more difficult because if you don't know, because of the boundaries. Now, if I change the boundaries, obviously you can find any value. Now, especially when you have boundaries, you can always double check your answer on the calculator. You can just say integral -3 to 3, right? And we have square root 9 minus alpha x squared. See what answer we get. We should get some answer. Okay, we'll wait for the answer. It should be 9 over 2 pi. Yeah, there. We got 9 over 2 pi. Okay, so now this brings us to a very important concept in circles or semicircles. Remember, when we have a circle and just assume we have a semicircle, right? And if we cut it this way, so obviously we know how to find the area of a segment. We know how to find, now we have a special way to cut. Remember, if we cut the semicircle in different forms, so let me give you all the forms, right? So you can understand it will help you in other courses like external exams like Tahsili, Qudrat, because they do all this. Right. So to find areas of, remember, if you cut the semicircle like this, or if you cut it at a central angle, right? If you cut the semicircle in sectors like this, right? And like this. So we can find the area of the sector, right? Remember, this is the center of the circle, so that's R and that's R. Now, if you want to find the area of this sector with the central angle, what do we find? How do we say the area is equal to half R squared theta? Theta must be in radians, okay? Convert the degree to radians. So we know how to find the area of that. Next part is how to find the area of a segment. It's very important, these concepts.
Mister, before you continue, how did you
Yeah.
get 0? If we plug in pi
Uh,
over 2, sine pi,
no. 2 times pi
oh,
over
sine
2.
2 theta, okay.
Yeah, 2 times pi over
Yeah,
2 is
okay,
sine
okay.
pi. Right.
Okay,
So
so
the sine
sine
of pi
pi,
is just
okay.
0.
Yeah, sine pi is
Sine of
0.
pi is just 0. I drew the
Yep,
graph. Yeah.
my
Right.
mistake, yep.
Excellent, guys. No. You are learning. It's important to ask all the questions. Any doubts you have, you got to ask. Now, remember, we also have a way of calculating the segment over here. What's a segment? It's basically, what's a segment? Segment is a small piece there, right? This piece here is a segment. Now, how do we calculate the area of the segment? This piece over here. There's a way to calculate the area of the segment with the central angle. So how do we calculate the area of the segment? Is area of sector minus the area of triangle. So area of segment, remember this is area of sector. Area of segment is area of sector minus area of triangle. What's area of sector? We did it, half r squared theta minus what's area of triangle? Half r times r sine theta. Half r squared sine theta. So now you can take out half r squared as a common factor, and we just get theta minus sine theta. This is the area of the segment. Now we have a special way to calculate the area. Now we can cut the circle in different ways. That's what I wanted to show you. So remember the circle over here. Now you can cut it in a different form. So let me take out all these and put it onto a coordinate plane, right? And now what we're saying is not cutting in this way, right? So we have X and Y axis here, right? And now we can cut the circle vertically like this, right? And we can cut it like this. Now we can find the area under the curve of this piece. Now, I don't know what you're going to call it. It's just a piece, right? So this is A to B. Can be any value, right? It can't be any value. It can't exceed the radius, obviously, right? So this is negative R to R, right? So to find the area here now, it will be integral A to B of the A squared minus X squared dx. See, these are the three different forms. So you have special ways to cut the circle to find the different areas. Are we good, guys?
What is x
So
in
this
that
is
case?
important.
So
What is
what is
that?
x in that case? X in that case.
No, it's a function. It's
Oh
this
yeah,
is the
it's a
function.
function.
It's area. It's like finding the area under the curve. There's a curve here. Or you
Yeah,
can
also,
talk about
yeah,
the
yeah.
entire curve of here. Right.
Yeah, okay.
It's a function. Example, it can be 9 minus x squared, square root of 9 minus x squared. And now if you want to find from 1 to 2, no issues. We can find it using this formula. All right, so let's continue. Next problem. Question 2. Now remember what you are doing. You are identifying a square root form. You're substituting a trig function. And you're checking the trig function. Does the square root form appear on my triangle? Yes. So it's a correct trig function that you are substituting. And you're converting the square root form into a trigonometric integral. And you're just solving a trigonometric integral, which we have done before in lesson number 21. Look at this form now. Right, so this form is also the same as the above form. What's the form of this integral? Only identify the square root form, which is a squared minus x squared. So we're going to say let, okay, let me do this thing here in the side. So we're going to say let x be equal to 4. Isn't it? It is 4 because square root of 16 is 4. 4 squared minus x squared. That's what it is. 4 sine theta. So what is dx? Dx is 4 cos theta d theta. Right. So now we have that. Remember what is sine theta? So sine theta, solving this integral for sine theta, it is x over 4. Now check your triangle. Does this square root form appear in my triangle? Then proceed by the trigonometric substitution. Let's check. So we can draw a triangle for this substitution that we have just done. Remember, this is equation 1 and this is equation 2. This part is just to check the triangle and the square root form. And we can use the triangle at a later stage. Now let's check. There's theta here. Sine is the opposite of a hypotenuse. So x here, 4 is a hypotenuse. And this is 16 minus x squared. So great. The square root form appears in my integral. We have used the correct trigonometric substitution. So we can proceed. So let's simplify the square root of 16 minus x squared now. Square root of 16 minus x squared is the square root of 16 minus, what is x? 4 sine theta. Squaring that, which is the square root of 16 minus 16 sine squared theta. We can take out 16 as a common factor. And we left with 1 minus cosine squared theta. Square root of 16 is 4. Square root of cosine squared theta, which is 4. Please write absolute value cos theta, which is just equals to 4 cos theta. And call this the integral, right? That's so great. The problem is solved now. We can say the integral is now equals to, what is square root of 16 minus x squared? We just solved that. That is 4 cos theta. Now next question, what is x squared? X squared is 16 sine squared theta. There's it here. X squared is 4 sine theta, right? So that is 16 sine squared theta. What is dx? Dx is 4 cos theta. Okay, d theta. So everything is substituted. Now forget about the previous part and try, sorry, you can't forget about the previous part because we need to put the integral back into x. It is indefinite. So there's no changing boundaries and stuff here. So now you can see 4 times 4 is 16. So we're getting 16 cosine squared theta over 16 sine squared theta, d theta. Now we can see that the 16s cancel out, right? Cosine squared over sine squared is cot squared, correct? Are we good, guys? Cot squared theta, cosine over sine is cot squared. Now, how are we going to integrate cot squared theta? Should we use an identity? Remember the identity was, for what was the identity for cot? It was 1 plus cot squared. 1 plus cot squared theta is cosec squared theta, right? You can go back and check, right? So you can just prove them. What was it?
Mr.
1
Can
plus
we use
cot
the
squared is cosec
rectangle?
squared.
Because we're integrating in pairs. We can use the
Are we
rectangle, right? The
I want to check.
sec,
I want to check.
tan, and yeah.
Wait. Let's check. Cosec,
Okay.
negative cosec, and cot. No, we're not integrating in pair. Where's the
No,
pair?
we can't. No.
So what we need to do is, we are integrating in pairs here. We can integrate this. So that's the reason why we need to change the cot squared into 1 minus cosec squared. Sorry, cosec squared minus 1. So cot squared theta is cosec squared theta minus 1. So change the cot squared to integral of, you need to understand why. It's not a pair here. This is not a pair. Cosec cot is a pair, but cot squared is not a
Yeah.
pair. So that's the reason why we are integrating. So remember to use these in conjunction. So we're changing the cot squared to cosec squared minus 1. Now we can integrate cosec squared. Great, because that's a pair. Okay. So the integral of cosec squared is negative cot theta. Because what's the derivative of cot? Negative cosec squared, right? So what's the derivative of negative cot? Cosec squared. What's the integral of negative 1? Negative theta, right? And plus a c. Now the question comes, what is cot theta? Remember we drew the triangle before? We got to use the triangle here now. We got to use that triangle in here. Now, what is, question is, what is cot? Cot is adjacent over opposite, right? Not opposite, tan is opposite, SOHCAHTOA, right? Cot is adjacent over opposite. What's the adjacent? Square root 16 minus x squared over x. And what is theta? Theta is, remember what was sine theta? Sine theta was x over 4. Sine theta was x over 4. So what is theta? Theta is sine inverse. So arc sine x over 4. So arc sine x over 4 plus cc. Right? And that's your answer. Crazy, right? That's your answer, guys. Are we good? Any questions? So step
Wait,
number
mister,
1.
I have a question.
Yeah.
How did we go from theta to x? Is it like we plugged
We
it
have
in
to.
with the
Yeah,
values that we had?
yeah. No, we
Okay.
didn't have any values. We are solving an indefinite integral.
No,
So you need to
as in
convert.
x equals 4 sine theta, we made that into theta equals sine arc sine x over 4.
Yeah, that's
Okay.
correct.
Okay.
It's the same thing as saying sine inverse.
Yeah.
You can also write your answer like this: square root of 16 minus x squared over x minus sine inverse x over 4 plus c. It's the same thing. Instead of saying
Okay.
sine inverse, we say arc sine.
Okay.
Right, because we saw, how do you get rid of sine here? You need to arc sine both sides. Okay, it's like using the inverse theory. Excellent, guys. Right, so that's my final answer, which is great. So what we need to do, identify the square root form, convert it into a trigonometric integral. Okay, identify the square root form, use the correct trig sub, make sure that the square root form appears in the triangle, so we know we are on the right track. Convert this entire integral into trigonometry, and then evaluate the trig integral. That's it. Right? It's so easy. It's just that it's long. What about the next one? What has a line there? Right. So now we have, what do we have here? We have x squared plus 4. So obviously we can't use the, what form? We can't use the first form. So we need to use the square root of x squared. So a tan theta. Okay, that's the trig sub we are going to use. So we're going to say let x be equal to a tan theta. But what is a? Remember the form is x squared plus a squared, right? What's the trig form? Square root of a squared plus x squared, or x squared plus a squared, same thing, because it's plus. So the value of a is 2. Okay, so what's the trig sub we're going to use? Let x equal to 2 tan theta, right? And this is an indefinite integral. If x is equal to 2 tan theta, then tan theta is equals to x over 2. I want to check my triangle. Am I using the correct trig sub? Okay, so let me check my triangle.
But you're using the triangle for checking, yeah? But if you will not check
Yeah,
during the exam
one
condition,
second.
what will happen?
No. You have to use the triangle to check and to substitute the answers at the end. You can see I use the triangle to find what is cot theta. You have to draw a triangle to check. And you have to use a triangle at the end to convert the theta back into x. Are we good? Hello?
Yeah, sir, thank you. Okay.
So theta goes inside here, right? Opposite over adjacent, so x over 2. And what's my hypotenuse? The hypotenuse is clearly a squared plus b squared. So basically 2 squared plus x squared. So that's 4 plus x squared. We can see that square root form appears on the triangle. So that is great. We have, which verifies that we have used the correct trig sub. Now find the derivative of tan theta. So dx d theta is 2. What's the derivative of tan? Derivative of tan
So I got
is
2
using
sec
the,
squared theta.
yeah,
2 sec squared
2
theta.
sec squared theta d theta.
D theta, yes.
Yeah. So if you use that, remember the summary, sec tan, that's what you are doing, sec tan, cosec, negative cosec, cot. So what's the derivative of tan? Sec squared theta. What's the derivative of sec? The other two, sec tan. So that's what we have. The derivative of tan is sec squared theta. Remember to push the d theta from the bottom to the other side because we're finding dx d theta. Right, so this is great. Now we need to change the square root form. So that to change the square root form, we have x squared plus 4, which is the square root of, what is x squared? X squared is, what is x? 2 tan theta. Right, now expanding all this, we're getting square root 4 tan squared theta plus 4, which is, take out 4 as a common factor, we left with tan squared theta plus 1. Square root of 4 is 2. Right? And tan squared theta plus 1 is the square root of sec squared theta, which is 2 absolute value sec theta, which is 2 sec theta. Isn't, because what is tan squared plus 1? Sec squared. Are we good? That's an identity. Tan squared theta plus 1. If you go right up, that's what we started off with. 1 plus tan squared is sec squared theta. So that's it here. And when you say square root of a number squared is absolute value. Drop the absolute value because of the boundaries. Anyways, call this the integral. Remember, we're always calling the main integral the I. So what's the answer for I? The integral is now equals to what is dx? Okay, 1 over, what is x squared? X squared is 2 tan theta. So 2 tan theta, let me just write it here.
Sir, x squared is, yeah, 2 tan theta squared, yes.
Yeah, 2 tan
Okay.
theta, and then square root of x squared plus 4, we simplified, that is 2 sec theta, right?
Yes.
And what was dx? Dx is 2 sec squared theta. Now you'll always have cancellation, right? So we can see the integral is now 1 over 4 times 2, that is 8, right? This is 4. 4 times 2 is 8. Tan squared theta times, okay, it's fine. Let's just write 4 tan squared theta times 2 sec theta. Now I'm going to simplify the top here now. Oh, we could have just simplified here, man. The 2 sec theta, the 2, 1 second. Remember the 2 and the 2 cancels out. 1 sec theta and 1 sec theta cancels out. So I can remove all this, right? And I can just write it on the numerator. Move the sec theta on the numerator. So remember the 2 and the 2 cancel out. 1 sec theta, 1 sec theta cancels out. So we left to sec theta, d theta. Now the question is, we have sec theta, d theta. How are we going to do this now? What's the derivative of sec tan? What's it? Should we use a u substitution, or how should we solve this? Okay. We can move the tan squared on top. What is 1 over tan squared? So let's move the quarter out. Right, 1 over tan squared is cot squared, is it? Yeah, remember 1 over tan is cot. Reciprocal identities, all right? So that's what we did now. But now if we are using cot, we should have cot and cosec, but now we got cot and sec. What if we try to convert this now? What's the method to solve this? Cot is clearly not a, should we change the cot into, let's change the cot into an identity. What is 1 plus cot squared theta? That is cosec squared theta, right? So let's do this. Quarter integral of 1 plus that is cosec squared theta. Yeah. This is just cosec squared theta times sec theta. No, we're not getting anywhere. We gotta try some other technique. Let's convert everything into sine and cos, right? We're not going anywhere with this. Right, so 1 second, sorry. We had the correct integral here. That's fine. Change the cot into sine squared over cos squared, right? And what is sec? 1 over cosine squared theta, right? 1 over cos theta, d theta. I just want to see if we have done everything correctly. Dx is 2 sec squared theta d theta. 2 sec squared theta d theta. What is x squared? 4 tan squared theta. And this entire thing simplified into 2 sec theta. That is correct. So our integral was correct. Now we are here. So what we have here is quarter integral of sine squared theta over cos
Wait, Mr. Isn't
cubed.
cot cosine over sine?
Oh, sorry. Thank you.
Yeah, no problem.
I put sine over cos. Thank you.
Yeah.
Cot is cosine theta, cosine squared over, yes, cosine squared theta over sine squared theta. Great. So now we can cancel out one cosine here and one cosine there. Now you need to understand why we are using this, okay? Because it's techniques of integration using trig integrals. You can clearly see when I substituted the identity, it did not work. So I'm trying to convert it into cos and sine. So now we have cancellation here, which is much more easier. So now what we have is cos theta over sine squared theta, t theta. Now this is nice because it's just straightforward u subs. Because if you make sine theta equal to u in the denominator, the derivative of sine theta is cos theta d theta. So problem solved, just u sub now. So when you say let
Oh, Mister, we
u
don't need to
equal,
do that. We can split the function up. We get
oh,
cosine over sine times 1 over sine. That becomes
yes,
cot times cosec, and that's an identity.
right, excellent. We can do that as well, right? But you can go and use a u sub, it's possible,
Yeah.
but it's fine. Quarter integral of cosine theta over sine theta dot 1 over sine theta d theta. Cosine over sine is excellent, Gustav. That is cot theta, and this is cosec theta. And what is cot and cosec? That's in
Negative
our,
cosec.
that's a pair. That's a pair. Cot and cosec, integral of cot and cosec is negative cosec. Yes. Quarter times negative cosec theta plus c. So I've got negative quarter. Now, what is cosec? Cosec, we got to get it from the triangle. What is cosec? Cosec from the triangle is, remember to use SOHCAHTOA here, hypotenuse over opposite. Isn't that what cosec is? Reciprocal of sine. Sine is opposite of hypotenuse, so hypotenuse over opposite is cosec. So quarter times square root 4 plus x squared over x plus a c. And that's my final answer, which is negative square root, let's write it neatly, over 4x plus c. Excellent. Good stuff, guys. Right, so you can't get stuck with integrating trig integral. You can, but you got to know the different techniques. When are you integrating in pairs? Right, I would have just used a u sub over here, right? But Rizwan figured this out. Excellent. Good stuff, guys. So that's the integral of this complicated thing here. It's not really complicated. You just gotta find the correct trig form and then substitute and solve. Right, so we have two more examples, guys. Right, just bear with me. Look at this one here now. Interesting example. And we'll verify this answer with the calculator as well, all right? We might get decimal values and stuff. Oh, this might be difficult, but don't get fascinated with the integral. Look at this, 4x squared plus 9 to the power 3 over 2. So we trying to check the form, all right? 4x squared plus 9 to the power 3 over 2 can be split up as 4x squared plus 9 to the power 1 times 4x squared plus 9 to the power half. Isn't same basis, we add the powers. We multiply the same basis, we add the powers. So this is the same thing as saying 4x squared plus 9, right? Square root 4x squared plus 9. Are we good, guys? Make sense?
You should make it one more time, no? Another 4x squared plus 9 to make it the power of 3.
No. It's to the power 3 over 2. 1 plus
Yeah?
half is 3 over 2. 1 plus half is 3
Oh,
over 2.
Yeah, you're
Right.
right, yeah.
Now we have a bigger problem because 4x squared plus 9 is not in this form. We need the form to be x squared plus a squared, isn't it? That's the form we need. But now we got a 4 there. Okay? We have a 4 there. So we're going to convert this. Watch what I'm doing. I'm going to use a u sub and change this entire integral to u. So I'm going to say let u equal to 2x. Okay? So what is du equals to? U is equal to 2x. So du is equal to 2 dx. You're just differentiating 2x, all right? That's what we have. So let me change this integral now, so we can get a better form. So we have, watch what I'm doing, integral of, now if x is 0, see, I'm substituting here now. Remember, these are u values. So if this is x values, and this is x value, let me change the bounds first. If x is 0, then u is also 0. If x is root 3 over 2, 2 times root 3 over 2 is just root 3, right? So that's u equals. Now, what is, remember, we got x cubed here. So what is x? X is basically u over 2, right? X is equal to u over 2. We'll convert everything, guys. See, x is equal to u over 2. Well, I made the boundaries easier. Okay, so x is equal to u over 2. So x cubed will be u over 2 cubed. What is dx? Dx is du over 2. What is 4x squared plus 9? What we have here is 4x squared plus 9. So what I wanted to do here was, I wanted to change the 4x squared like this. The reason why I did this, I said let u equal to 2x because I identified this inside over here as 2x squared plus 9. Okay, and the square root of 2x squared plus 9. That's what I said. That's the reason why I said let u equal to 2x. Okay, so what is 4x squared plus 9? 4x squared is just basically u squared plus 9. Okay, square root u squared plus 9. Are we good, guys, so far? Now see what you have here. You see you got u cubed on top and you got 1 over 8 here. 1 over 8 and you have a half here. So see, if I take this half outside the integral, I take this 1 over 8 outside the integral from here, we're getting 0 to root 3 of u cubed du over this integral, u squared plus 9 over the square root of u squared plus 9. Are we good, guys, so far? Make sense? Are we good? That's what we have so far. Look at the simplification. Now,
Mister, I have a quick
I'm-
question.
yes,
The calculators are allowed in the exam, AP exam, right?
yeah, because after you get your final answer, I'm going to double check. Right, listen, guys, this is the step where I came towards. Now we can identify the form. Now, what I'm going to do is you are allowed, because it's a definite integral, you can change all your variables back into x. So this is 1 over 16, 0 to root 3 of x cubed over x squared plus 9 into square root of x squared plus 9 dx. Because how are you going to solve this on the calculator? By using x variable. It's just a variable change, that's it. You're just saying let u equal to x, okay? You didn't change the integral at all. It's just the u variable changed to x variable. You are only allowed to do this in a definite integral, okay? You can't do it in indefinite integral. You can't just put your own variables there and solve. Now we can forget about what we have done previously. This is your new question. So now we can identify the form. The form is x squared plus a squared, isn't it? X squared plus a squared. So where the value of a is 3 because we have a 9 here, right? So the value of a is equal to 3. So we're going to use the substitution. Let x equal to 3 tan theta. 3 tan theta, so tan theta is equal to, sorry, let's find dx, the derivative. So dx is now equal to 3. Derivative of tan is sec squared theta d theta. Now, what is tan theta? Tan theta is, we're checking the triangle now. Tan theta is x over 3. I'm going to draw the triangle and check if the square root form appears there. And that's it. You need to check if the triangle, the square root form appears here, right? So I have theta here, right? And opposite of adjacent, x and 3. Yes, opposite of adjacent, and the square root form does appear, which is 9 plus x squared, or x squared plus 9, same thing. So it does appear. So great, now we can start by changing the square root form into a trig identity, right? So square root of x squared plus 9, square root of what is x? 3 tan theta, we're squaring it, so 9 tan squared theta plus 9. I just squared it, right? Instead of writing x squared, 3 tan theta all squared. Take out 9 as a common factor, we left with tan squared theta plus 1. Square root of 9 is 3. Tan squared theta plus 1 is sec squared theta, which is 3 absolute value sec theta, which is 3 sec theta. Right, so great. That is 3 sec theta. Now remember, what is x squared plus 9? X squared plus 9. Oh yes, we also have what is x squared plus 9. X squared plus 9 should be 9. It should be 9. You can't take the 9 out now because x squared plus 9. What is x squared plus 9? X squared plus 9 should be 9 sec squared theta. Because remember, we also need to simplify that. I just got that from this substitution here, 9 sec squared theta. I need to put this 3 back inside. Now, you also need to change the boundaries. So the integral is now 1 over 16 integral. Now, what is when tan is 0? Remember, tan theta is equal to x over 3, right? If x is equal to 0, I'm changing the boundaries because it's a definite integral. You're changing everything in terms of trig now. If x is 0, if x is 0, we're getting tan theta is equal to 0 over 3, 0. So tan of 0 is 0, right? So theta is equal to 0. Remember the tan graph goes like this. That's negative pi by 2, and that's pi by 2. Right, now, next one. What about the value of root 3? If x is equal to square root of 3, then we have root 3 over 3. Tan theta is equal to root 3 over 3. I think this is a special triangle. It's the same thing as saying 1 over root 3, right? And if I draw the, oh yeah, you can use a calculator. What is tan inverse 1 over root 3? Shift tan 1 over square root of 3, right? You are allowed to use a calculator, right? Let's try tan 60. Tan of 60 degrees. Oh, no. Can't try tan. My calculator is not in radians mode. Radian, tan of 60. No, put it in degree mode here. Then I can convert it into tan 60 is root 3, right? So it should be tan 30. Tan of 30 is root 3 over 3, right? So that's 30 degrees. So remember, theta is equal to 30 degrees. I can't use degrees. Convert it to pi by 6. Okay. Remember, what you're saying is you're going to put it in radians mode. 1 second. Shift mode, go to radians, option 4. Shift tan inverse root 3 over 3. Square root 3 over 3. Okay. So there. 1 over 6 pi, or pi by 6. So this is pi by 6, the upper boundary, the lower boundary is still 0. Okay? So great, guys. We change the boundaries here. So we have changed the boundaries of the integration. Now it's all a matter of fitting it in. What is x cubed? What is x? X is 3 tan theta. So x cubed will be 27 tan cube theta. What is x squared plus 9? That is 9 sec squared theta. And what is square root of x squared plus 9? The square root of x squared plus 9 is 3 sec theta. And now we still got one more thing left. So we change the boundaries. We change the x cubed using this trigonometric substitution. We change this, we just have the dx left. What is dx? Dx is 3 sec squared theta d theta. Right, so now we can see some cancellations happening here. We can see the sec squared theta and the sec squared theta cancels out, right? We can see the 9 times 3, right? And the 27, they all cancel out, okay? 9 times 3 is 27. So that one, all that cancel out. So what am I left with? I'm going to move the 3 outside. So I'm left with 3 over 16 integral 0 to pi by 6 of 10 cubed theta over sec theta d theta. Now you have simplified this entire thing. You simplified this integral into this form over here. Now all you need to do is think about this form and see what you're going to use. So should I change the 10 cubed into back to normal, like how we were doing sine cubed over cos cubed? Maybe. So what we have is, we'll try that method out. 3 over 16 integral 0 to pi by 6. Tan cubed is sine cubed over cos cubed theta. And 1 over sec is cos. I can just take this sec, convert it to cos. So cos up. You understand why? Because remember, 1 over sec is cos. 1 over sec theta is cos theta. Okay? So remember that. So, okay. So I can see that these things cancel out. 1 cubed and the cos cancel out. So I just have cos squared in the denominator. Right? So I've got 3 out of 16 integral 0 to pi by 6 of sine cube theta over cos squared theta d theta. Okay. So that's what I have so far.
But we
How
should
should we-
continue, yes, that? Continue doing
Yeah, we have
in that case.
yeah, we have to think about what we have to do here now. Sine cubed.
We can take out the sine and make it sine square over cosine square. It will be tangent square like this, or you can do it, write it
Yeah,
now.
No,
okay,
mister, we just
can
did
do
that,
that.
didn't we? We just converted it out of the
Yeah,
tan cubed.
yeah,
So I was
we
thinking
had,
we could use the identity.
what identity? Sine squared
We
plus cos
do,
squared is equal
yeah,
to 1.
sine squared plus cos squared is 1. So we do cos
Okay.
squared is equal to 1 minus sine squared,
Wait, 1 second. You are thinking about changing the top, right?
the bottom.
Why you want to
Have it
change the
all
bottom?
sine. Have it all in sine.
How will that work then? Because if you're going to change this in terms of sine, we still need some kind of derivatives to appear. I was thinking something like this. You're going to get stuck if you're going to use 1 minus sine squared. I was thinking something like this, 0 to pi by 6. Change it into sine squared theta times sine theta over cosine squared theta d theta. then changing the sine squared on top into cosine squared. That's what I was thinking.
Okay.
Yeah, that will work. Why it will work? Because you can use a u sub. You can say let u equal to cosine theta. What is du equal to? Negative sine theta d theta. And we got sine theta d theta already appearing over here. Okay, we can use the second equation to simplify it. So watch here. Are we going to continue? That's 3 out of 16. Integral 0 to pi by 6. No, we can't say 0 to pi by 6. We are using u sub, right? We have to change the boundaries again. What is sine squared theta? That is 1 minus cosine squared theta sine theta d theta over cosine squared theta. That's what I've wrote. I've just changed the sine squared into 1 minus cosine squared. And that is still 0 to pi by 6 because I did nothing to the integral. Now I'm changing the integral, substituting equation 1 and equation 2 inside here. So what is 1 minus cosine squared? Cosine is u. So that's 1 minus u squared dot sine theta d theta is negative du multiplied by negative on both sides. So that's negative du over u squared. And this is a basic integral to solve, right? Now remember to change the boundaries. If theta equals 0, if theta equals 0, you're going to have u equals cos of 0. What is cos of 0? 1, isn't? Is that correct?
It's 0, yeah.
No, no, no.
1,
Cos,
sorry, 1.
u
Yeah,
equals
correct.
cos of 0, which is equals to 1. So you're going to change it to 1. And if theta equals pi by 6, then u equals cos of pi by 6. What's cos of 30? You can just use a calculator. Cos of pi by 6, all right? Cos
It's 1 over 2?
Pi by 6. No, sine of pi by 6.
So
Sine
it's
pi
root
by
3
6
over
is
2.
root 3 over 2. Yeah. You can use the 30, 60, 90 triangle, right? That's pi by 6 is half, and that's pi by 3. That's root 3. Root 3 over 2. Adjacent over hypotenuse, correct. Now, that's all right, guys. Now we're almost done solving. Remember to take the negative out of the integral, right? Negative must go out of the integral. Now we're integrating the, we need to look at the form of the integration. So you got 1 to root 3 over 2. That's 1 over u squared, which is u to the power negative 2. I'm splitting up like this, guys. Watch here. Right? And like this. So let me write it out for you so you don't forget. Okay. No need to take the negative out of the integral, is fine. Let's multiply by negative 1. So that's negative 1 over u squared. Negative times negative is positive u squared over u squared du. Right, so let's keep that number positive on the outside, 3 over 16. Integral 1 to root 3 over 2. What about this one? That's u to the power negative 2, the negative, right? Plus 1 du. Integrating this is going to give us u to the power negative 1 over negative 1 plus u 1 to root 3 over 2. Let me simplify this inside so you can actually see what we are doing here. That is u, and this is negative, negative cancel out, u plus 1 over u. That's it. Now, let me substitute root 3 over 2 inside here. If you substitute root 3 over 2, you're just going to get root 3 over 2. And 1 divided by root 3 over 2 is 2 over root 3. Subtract the lower bound, 1 plus 1. 1 plus 1 over 1. Right, so now that's the simplification. 3 over 16. What is this? Let's see.
2 over 3, 2 over 3 like this. We'll do it, no?
This is 2 root 3. 1 second. 2 root 3 And
It was
root
4.
3 times root 3 is 3 plus 4. Good. Minus 2. We almost there, guys. Let's take 3 over 16. 3 over 16 times that's 7 over 2 root 3. I'm going to multiply by root 3 over root 3. Subtract 2. It's just simplification, man. I'm not using a calculator here, obviously. That is 7 root 3 over 2 times 3, which is 6. All right. Minus 12 over minus 12 over 6, which is 2. All right. Okay, this is a very fancy answer. All right. So this is what we're getting. 3 into 7 root 3. 3 times 7 root 3 minus 12 divided by 16 times 6, which is 1896. And let's see what's the decimal value of this. 3 over 96. Can we take 3 and divide by? Yeah, 3 over 96 is 1 over 32. So 7 root 3 minus 12 over 32. So I want to check this. 7 square root of 3 minus 12 over 32. My answer is, whoa, my answer is so tiny. 3.886 times 10 to the power negative 3. 3.886114 times 10 to the power negative 3. In other words, you're dividing by 1,000, right? So that is 0, 0,003,886. Is that correct? You have to shift the decimal comma to the left. 1, 2, 3. Decimal comma goes there. So 003. Yeah. Now, I want to check this answer on the calculator, right? Let's type this entire thing on the calculator. So integral 0 to square root 3 over 2. And what we have, x cubed alpha x to the power 3 divided by 4 alpha x squared plus 9 to the power, I'm not going to say 3 over 2, I'm going to say 1.5, right? To the power 1.5. And we got a dx at the end. Just press equals there. We got 3.886. Are we good, guys? Okay,
Yes,
I typed it on the calculator, we ended up with the exact same answer. It's just that it's long. That's it. All right, guys. Last example. Okay. Dx over. So this last form is the third form here, right? Where we have to use the a sec theta form, x squared minus a squared. X squared minus a squared. So the value of a is 3 here, because 3 squared is 9. So when I say let x equal to 3 sec theta. Now what is the derivative of sec? Sec tan. Okay. Now what is sec theta here? We need to check the triangle. Sec theta is x over 3. Right, so let me draw a triangle and see if that square root form appears there. It's easy because if you know the forms, then it's very easy. That's why we say you need to learn the integration techniques to master integration, all right? So there's theta here. Sec is hypotenuse over adjacent. So hypotenuse is x, adjacent is 3. So the square root form does appear in the integral because the opposite will be the hypotenuse squared minus the adjacent squared. So that will become x squared minus 3 squared, which is x squared minus 9. So great. Now remember, this is an indefinite integral. So you can't do fancy stuff here. You got to integrate it in terms of trig and then why did they give us x is greater than 3 here? Because if you try to substitute any other values, you're going to have square root of a negative number, which will become undefined. That's the reason why they give us x is greater than 3. So forget about this. Don't worry about this. All right, just focus on this integral. So the integral is just basically equals to this. Now, let's simplify square root of x squared minus 9. Square root of x squared minus 9 is square root of, what is x squared? X squared is 9 sec squared theta minus 9. Take out 9, we got sec squared theta minus 1. Now, you know sec squared theta minus 1, square root of 9 is 3, is tan squared theta, all right? That is 3 absolute value tan theta, which is 3 tan theta, okay? Now, let's convert this integral. So the integral is now equals to integral of, what is dx? Dx was sec theta, tan theta, d theta, but there was a 3 there. Right. So we got 3 sec theta, tan theta, d theta, which is dx over, what is x? X is, what is x? X is 3 sec theta. And what is square root of x squared minus 9? The square root of x squared minus 9 is 3 tan theta. Wow, it's such an easy integral now. This one, simple, right? So it doesn't mean that every time the integral will be difficult. It's such an easy one. Because sec theta cancels out, tan theta cancels out, 1, 3 and 1, 3 cancels out. So you just got 1 over 3. What's left with? What are we left with? 1 over 3 integral of 1 d theta. Make sense? Guys?
Okay.
Yeah. Guys, so that's so easy. Everything canceled out. We didn't even end up with a trig integral. So not necessarily we always end up with a trig integral. There's a case where we don't end up with a trig integral. And this is so
do we
easy
have to
because
put 1 d theta, or can we just put integral of d theta?
just integral of d theta,
Okay.
because remember the coefficient of it's implied that it's a 1. You don't have
Yeah.
to. The reason why I
Okay.
put a 1 there, so you viewers can understand what we are
Yeah.
doing here. So we got 1 over 3. What's the integral of 1? Theta
Theta.
plus c. Right. Now what is theta? Theta is from here. Theta you got to transform from here, which is arc sec. Can you see here? We know that sec theta is equal to x over 3. So what is theta equal to? Arc sec x over 3. Okay. So what is this equal to? 1 over 3 arc sec x over 3 plus c. Now the same integral, note, the same integral can also be solved in the previous technique where we use, you can try solving the same integral in this technique with using the arcsec form x squared minus 9 by completing the square, right? You can look at lecture number 21 and solve using the inverse trig forms, right? So use inverse trig forms. And what was the inverse trig form? Let's go back and check. Sorry, lecture number 22. Right, so remember the inverse trig form, the 3 forms that we have. See, look at this form here. Right? Are we good? So you got to complete the square here, and it's the exact same form, this integral here. So you can use the arcsec form over here. Right, guys? Make sense? Are we good?
Yep,
Yeah.
makes sense, mister.
Yeah, so you can also use the previous example to solve this, and you come up with the same answer: 1/3 arcsec x over 3 plus c. Yeah, this is great.